Welcome to video on binomial distribution for FRM1. Binomial distribution is one of the most important question types in quant section of FRM1. As you know, there are 20 questions out of 100 on quants in FRM1 paper, and typically at least one question. That means the weightage of binomial distribution in quant section would be about 5%, and at times you can also have two questions based on binomial distribution. Now, when we talk about binomial distribution, there are certain underlying assumptions that are made. Firstly, the experiment consists of n number of trials. Now, if I consider an experiment of tossing a coin 100 times, each of my trial consists of tossing a coin one time. That means my experiment consists of 100 such trials, and each trial is independent of others. So what happens in my current trial, that means whether I get heads or tails, is not going to affect the outcome of any other trial in my experiment. Then third assumption is each trial can end in either success or failure, and no other outcome is possible. In this case, if I am tossing a coin, I can get either heads or tails. There cannot be any third possibility. And the probability of success or failure in each trial is same for all the trials. Now, what is meant by success and failure? We are going to spend a little bit more time on that. However, at the moment, let us understand that probability of success is for each trial is same for all the trials, which means that if I am tossing a coin and I am interested in calculating the probability of getting heads, then success to me means getting heads, and the probability of success, that means probability of getting heads, is constant for all the trials. Now, when we are talking about success and failure, so what is meant by success and what is meant by failure? In terms of binomial distribution, success means outcomes that are favorable to our event of interest. Now, continuing with the example of tossing a coin, if I am interested in calculating the probability of getting, say, heads, in that case, getting heads is success for me, and anything that is not favorable to our event of interest is failure, which means that getting tails is failure. Now, qualitative considerations do not apply at all in determining success and failure. For example, if we want to calculate the probability of breakdown of a machine component, in that case, success is breakdown of the component for me. Okay, so let us not ask the question, how can breakdown of a component be a success? So the important point to remember is success are the outcomes that are favorable to our event of interest, and failure, that is anything that is not favorable to our event of interest, is failure. Now, if we are throwing a die that has 6 faces, okay, and if we are interested in calculating the probability of getting, say, 3 on the die, then getting 3 is a success, and getting anything other than 3, that is 1, 2, 4, 5, and 6 on the die is failure for us. Now, as we have seen, tossing a coin number of times, say 100 number of times, is a perfect example of binomial distribution, because if we toss a coin 100 times, our experiment consists of 100 different trials, and definitely all the trials are independent, and each trial can end only in success or failure. There cannot be any third possibility, and the probability of success remains unchanged for all the trials. So all the assumptions of binomial distribution are satisfied, and because of that, this is a problem of binomial distribution. Now, let us solve one simple example based on binomial distribution. Andrew, Bill, Charlie, and Dennis are 4 bright students in a class, and the probability that each of them will secure an admit from Stanford University is 0.8. Then what is the probability that 2 of them will secure an admit from Stanford? So this is a question. Now, before we actually begin solving the question, let us confirm that this is a question on binomial distribution. This experiment consists of 4 trials because there are 4 different students. And Andrew's admission or otherwise to Stanford is independent of what happens to others. So whether a student gets admit from Stanford or not depends on only his application. It's not dependent at all on what happens to others. And each trial can end in either success, that means student getting an admit, or failure, that means student not getting an admit, and no other outcome is possible. And the probability of success is same for all the trials. So how do we know that? Because that was given in the problem that the probability that each of them would get an admit from Stanford is 0.8. So all the assumptions of binomial distribution are satisfied, and therefore this is a problem of binomial distribution. Now how to actually solve this? Okay, let us see. Now, when we say that 2 students secured admit from Stanford out of 4, it also means that the remaining 2 did not secure admit. Okay, so we have following possible scenarios. Firstly, say Andrew and Bill got admit, and Charlie and Dennis did not. Similarly, in the second scenario, Andrew and Charlie were admitted, while Bill and Dennis were not. So as you can see here, there are 6 different scenarios that are possible. And then what is the probability of each scenario happening? Now, Andrew and Bill will get an admit to Stanford with probability of 0.8 each. Okay. Therefore, the probability that both of them will get an admit from Stanford is 0.8 square. And similarly, Charlie and Dennis will get an admit from Stanford with a probability of 0.8. That means the probability that they will not get an admit from Stanford is say 0.2, 0.2 each. Therefore, the probability that Charlie and Dennis both will not get an admit from Stanford is 0.2 square. And therefore, the probability of first scenario happening is 0.8 square into 0.2 square, as you can see in this table. And as you can see, this probability remains same for all the 6 scenarios. Okay. Therefore, the total probability is 6 into 0.8 square into 0.2 square. Now, in general, the probability of R successes out of n when you have binomial distribution is given by NCR, that is combination of R things taken out of n multiplied by P to the power R, that is probability of success to the power R multiplied by 1 minus P to the power n minus R. So in this short video, we have introduced the concept of binomial distribution. Contact us at this email address, that is frmbuddy@gmail.com, for second part of the video. And the second part is going to be a paid access. However, the charges are going to be absolutely nominal. It would be around 50 Indian rupees, or which could be say 1.49 American dollars for video with 5 solved examples. And these videos are not ready as of now. We are still in the process of creating the videos and uploading them. So videos will be available starting from August 2014 on different topics related to FRM-I. And last but not the least, also visit us on our Facebook page at www.facebook.com/FRMBuddy. Thank you.